Hello everyone, I am Guru Prasad. Today we are going to explaining about the cloud computing topic. So that is visualization in high performance computing clusters. So that's also called as HPC. So the HPC clusters generates the massive data sets. So effective visualization transforms raw data into the insights. So this presentation will be cover the what are all the challenges, tools, and the future trends in the HPC visualization. So we'll learn how to make the sense of big data. So let's start the video. So the data delug in HPC, a visualization challenge. The main focus is about the challenge. So the first one is the scale of data. Scale of data will be the big challenge for the HPC because it contains a large amount of the big data. So HPC simultaneously produces data sets from the terabytes to petabytes. So traditional visualization struggles at this scale. So the second challenge is analysis of the bottleneck. So the climate models generate the terabytes of the data per run. So visualizing the temperature, pressure, and the wind speed is the difficult. So these two are the main challenges of the HPC. So the challenge is efficiently rendering and exploring the massive data. So this bottleneck hinders scientific discovery. So the next we'll move on to the importance of the visualization in HPC. So the first importance is pattern recognition. It enables the pattern recognition anomaly detection in a complex simulation. So if the simulation is complex, then it will enable the pattern recognition to overcome this complex simulations. So next one is the validation. So validating the simultaneous results against the experimental data through the visual comparisons. So the validating the simulation results against the, so it will take away for the experimental data for the visual comparisons. So the next one is the communication. So the communication leads to the facilitating collaboration and the communication of the research findings. So for example, material science simulation visualizing stress distribution help identifying the failure points. So the visualization accelerates the scientific discovery. So the next one is the key visualization techniques for the HPC. First one is the volume rendering. Second one is the isosurface extraction. Then the third one is the streamline visualization. The first one is the volume rendering. The direct visualization of 3D scalar fields. So this is the direct visualization of the 3D scalar fields that's called as a volume rendering. So the useful in the medical, it will be useful in the medical imaging and fluid dynamics. So the next one is isosurface extraction. Isosurface extraction is identifying the surface of the constant values. So it will be useful in the mapping temperature distributions. So the next one is streamline visualization. Streamline visualization is representing a fluid flow, electromagnetic fields useful for the visualizing the ocean currents. So it will be importance driven rendering helps to focus on the key simulation aspects. So the next one is the what are all the tools which we can use in the HPC. The first one is the ParaView, second one is the Visit, and the third one is the VTK. VTK, which is the library of the 3D graphics, and the ParaView is the open source application for the large data sets, and the Visit is a tool designed for the large scale data. So these three are the main tools and the libraries of the HPC. Then next move on to the remote visualization and collaborations. So first one is the remote rendering, and it will be collaborate. It will leads to collaborative visualization. Then it leads to web-based visualization. The remote rendering is the visualization on the remote HPC resource. The next one is the collaborative visualization. Collaborative visualization is multiple users can interact with the real time. Then the third one is the web-based visualization. Web-based visualization is the applications on a web for the access. So the technologies like the NVIDIA, the graphics company, NVIDIA Index, HP Remote Graphics software are the key for this one HPC. So the next we'll move on to the what are all the emerging trends in the HPC visualization. First one is the in situ, second one is the ML, that's called machine learning. Then third one is the immersive VR or the AR. First one is the in situ visualization with the simulations code. So next one is a machine learning. Machine learning is the highlight to importance features, and it also contains the core branch of it also contains the main branch of like AI. So the next one is immersive VR or the AR. It will create the immersive experience. So the next is, so the final conclusion for this HPC visualization will be, the first one is the crucial investment, second one is the transformative trends, third one is the key benefits. Crucial investment means the infrastructure is the key for the scientific advancement. So the infrastructure will plays a major role for the advancement or the implementation of the HPC technology. And the transformative trends is insight or the ML are the emerging. So that ML and the AI or like the advanced technologies are the transformative trends in HPC visualization. Then the third one is the key benefits. What are all the key benefits which we have discussed in HPC visualization? That and all plays a major role for the visualization of the HPC. Then key benefits is it enables a knowledge extraction. So we can exchange our knowledge with one system to another system or the one network from another network. So investment in HPC visualization infrastructure and expertise is crucial for the scientific progress. So these are all the HPC visualizations topics. So I hope you guys understood all these HPC visualization related topics. So I hope you guys enjoy this video. Please like, share, subscribe the video. So thank you.